Hello, everybody. Good morning, good afternoon, good evening, wherever you are in the world. I hope you're having a brilliant day. And welcome back to our second episode of the Polyhedra Show. So, we've got a really, really exciting fireside chat planned for you guys today. Today, we're going to be diving into Expander, which is a groundbreaking ZK proof system that's truly changing the landscape of AI and blockchain. We'll also be diving into some details about our Explore Expander Bootcamp initiative, which is developed with initiative to help develop Ethereum's Bean Chain infrastructure. So first up, I'm really excited to introduce Eric Vreeland, our Chief Strategy Officer at Polyhedra. With our industry moving so quickly, I think there's only a handful of people who can truly see all the pieces on the board, and Eric is definitely one of those people. So it's really exciting to hear from him today. And we've got Zhenfei, our chief cryptographer at Polyhedra. He is at the cutting edge of everything that's happening in zero knowledge technology. Definitely been extremely influential in the development of Expander and one of the most influential figures behind its success. So I can't wait to hear more about that today. So with that, let's dive right into the fireside with Eric and Zhenfei.
Thanks, Tony. And again, thanks to everyone who's joined us today. I appreciate you taking the time out of your day to learn more about Expander and our Explore Expander Bootcamp, which we're really excited to share more details around. Again, I am Eric Vreeland. I'm the Chief Strategy Officer at Polyhedra. A little bit about my background. I've spent my entire career at technology startups. I've worked across industries from MarTech to AI to blockchain. I've worked at seed stage startups out of garages all the way scaled through to IPO. And most recently, but prior to Polyhedra, I was the head of marketing at Layer Zero, which is actually where I met the Polyhedra team when they were working on ZK Bridge and the ZK Light Client Oracle, which is now the Polyhedra DVN. When I left Layer Zero, Polyhedra was ramping up on the go-to-market side of the business, and I was already incredibly impressed with the team. And having worked closely with them, it was an easy decision for me to join and help as Polyhedra not only continue to expand to grow ZK Bridge, but launch new products like EXP Chain, like Expander, and continue to bring leading AI and zero knowledge products to market. I really enjoy working on Web3 because not only because of the potential that decentralized technology brings to improve the world, but also because there are no playbooks. So it allows you to think creatively and really problem solve, and it keeps things interesting because there's no script you can follow. You really have to figure it out as you go along, and the job definitely is never boring. So with that, I will also reintroduce Zhenfei Zhang, our chief cryptographer. Zhenfei, I just shared my kind of short path to Polyhedra. Why don't you tell us a little bit about your path and what got you started in cryptography and how you eventually found your way to Polyhedra?
Right. So I'm a trained cryptographer. I did my PhD in cryptography back in 2008-ish. That is time when the quick gentry invented the fully homomorphic encryptions. And some of the that is also a hot topic in the market at the moment. But long story short, after I finished my PhD, I get into this blockchain space. That is when I met the algorithm team as a cryptographer. That will be a really interesting problem to solve. And one thing lead to another. I end up doing a lot of the ZK related research. When I get deeper into this space, I realized that there's so much new ZK stuff in ZK technology in the academia that hasn't been really transferred into industry. That was around 2018, where people were still talking about Zcash, and ZK rollups was still just a Eureka, and nobody has really dived deep into concretize it. So I thought that this would be really interesting, and and then that is also the time that I learned about the work that our co-founder Tian Chen and the team was doing when they were at Berkeley. I read that paper. It's called Libra, and then there's a few paper after that, a few follow up work after that. What they have achieved is really a linear time prover. What it means, say, if I want to prove some statement, I just need to take the linear time, so the O(n) time to go through the proof. I mean, without talking into too much details, this kind of proving system is, from my point of view, it's a next generation proof system. It's compared with the existing one, where you really take a super polynomial time. That means if I have a statement, I take like n log n time to actually prove it. So from my first principle, that you have something really advanced, but you actually don't have the real. I mean, that's a huge opportunity for me to knowledge transfer this kind of academic idea into the industry, which is something that I think I'm quite good at. So that's where I learned about that project. I learned about this their work, and learned about this Polyhedra project of breeding liquid bridge, and that's. I think that would be my opportunity to help the team to really bring their innovations into industry and try to utilize these technologies to build a better blockchain. So I guess
that's absolutely.
Yeah,
and I know you spent a little bit of time at the Ethereum Foundation. Mm-hmm. Did you have a research? I mean, I'm assuming it was in this context of zero knowledge and cryptography, but can you give us a little more insight into your research and what you focused on during your time there?
Yeah, so I had two focuses where I was with Ethereum Foundation. One is called so-called this post-quantum cryptography, which is the existing the existing cryptography used by either Ethereum or Bitcoin or many other chains has some vulnerability against the quantum computers. That means if I have a quantum computer, I probably will be able to spend your token or something like that. And one of my research goals was try to make sure that that doesn't happen. The other research direction that I was there is to practice zero knowledge proofs, basically. And you will see that nowadays, like in the Beam chain proposal, there are so heavy usage of the zero knowledge proof systems, building say consensus, building the single source of finality, building a abstraction, all those things. I think, yeah, like my task there was trying to figure out. I mean, with a lot of talent people, we figure out together what's the best way to practice zero knowledge proofs.
Great. And I know we're going to get into this a little bit later, but I know, quantum computing is a hot topic right now because there's a lot going on in the news. I've seen a lot of comments on Twitter. Oh, we're all screwed. Bitcoin is going to be broken. So we can get into those details later, but it is exciting to hear that you've spent a lot of time thinking about quantum computing and how it impacts the blockchain. And I know we have some more to discuss around that in the boot camp later on.
Yep.
For the non-cryptographers in the audience, and you talked a little bit about this earlier with regards to the linear time versus super polynomial time. Can you explain the primary differences between Expander and the other proof systems? What facilitates these performance improvements? We've seen the benchmarks that we've just put out. We've seen that, Expander is extremely performant when compared to, let's call them, the previous generation of proof systems. What is actually causing these performance improvements? What is the breakthrough that we found?
So I think we should give credit to the academias. The original scheme was actually established like almost 20 years ago. It's called the GKR proof system. when it was initially invented, it wasn't meant to build a ZK Snarks, but then people figure out ways to convert it into a ZK Snarks and so far so forth. The performance scan that we are using, or we are observing, is actually from. Am I losing? Oh, hi. The performance scan that we have observed so far. Am I good?
You're
okay,
good.
Okay, cool. Yeah. Sorry, internet. So yeah, it's mainly from the theoretical advance. Say so meaning that if I have a better algorithm, it should run faster, and then that is a major source of the of why we are so fast. Although we should also give some credit to our engineering team, we have spent tons of effort to actually realize this advancement from the advantage in theory. We actually built the GPU accelerators. We built the fast compilers, fast provers, to make sure that the theoretical advancement actually translate into practice. Yeah, so I guess it's a combination of both really great engineering effort and theoretical improvement.
Got it. And for those that may not be familiar with GKR, GKR is the initials of the inventors of GKR protocol and stands for Goldwasser, Kalai, and Rothblum. Is that correct?
Yes.
All right. So make sure that we give credit where it's due. But yes, so if anyone wants to look it up, read more about the GKR protocol. We have a lot to thank and a lot of credit to give to the authors of the GKR protocol. Recently at DevCon, Justin Drake shared his proposal on the Beam chain and his proposal for the long-term or 5-year roadmap. Can you give us your thoughts on that roadmap and give us what are your opinions on the roadmap?
I think Ethereum is trying to do really great things here. Like, I mean, I'm biased, obviously, so take it with a grain of salt. But I think the point of the decentralization or the reason that we're so passionate about Web3 is try to get a decentralized world where everybody can participate in one way or another. At the moment, Ethereum has this limitation where you only have so many. You can only have so many validators for Ethereum. Like not every Ether holder can validate, and the scope of Beam chain is actually really spanned to really enable say 1 million validators to be able to participate in the consensus. That makes a huge difference. Like Ethereum is already so much better compared with all its competitors, but moving to the 1 million validators is the next stage, next generation. And to be able to do that, you will need a lot of things. You will need new solutions. You will need to implement those new solutions, and you will need time to test out that new solutions are good. So it's reasonable for the Ethereum on the conservative side to budget 5 years to build everything together. But in the meantime, I'm also hearing a lot of criticism on the fact that it takes 5 years, and people think that they can do 2 years, or maybe some aggressive guys will say like they can do it today. I generally don't have an opinion on that. What I can say is like I'm going to quote a famous quote like talk is cheap. Let's build the code. So what I'm trying to propose to all the people or the developers, the whole community is say, let's try to build those components, building blocks one by one. Once we have all the building blocks, we assemble them together. That's your Beam chain. It may take 1 year, it may take 5 years, but let's start build now, and we may be able to accelerate this roadmap. Just don't worry about the time frame. Just start building. Yeah.
Absolutely, and I think maybe something that people are considering is potentially the technology could be built. And I like your approach of building it in these modular pieces, and then let's prove that we can get the technology to work. I think something that's often taken for granted is, with Ethereum, there's $500 billion at stake. And so, they have to be particularly conservative when it comes to changes because this is there's a lot of value at stake here. Of course, a team with nothing to lose and no value on their blockchain could probably implement this and do no testing whatsoever and roll it out very quickly. But there are other factors at play here. And I want to go back to something that you said at the beginning of the question when you were speaking to improving the validation mechanism and allowing anyone to be a validator. When you're talking about this, are you referring to this idea of kind of moving from a sync committee to full consensus where every validator's utilized in validating a transaction?
Yes, precisely. So at the moment, the Ethereum uses so-called BOS signatures to aggregate all the votes. So there's a limitation. I mean, BOS signature allows you to aggregate, but there's some practical limitations of how many people that how many signatures you can aggregate within a short period of time. So what Ethereum try to overcome this limitations, they have this sync committee, and then you only need to aggregate 1,000 signatures per block, and these 1,000 people will represent a wider list of the validators, say 1 million validators. This works for the Beam chain, for the Beacon chain, but for Beam chain we want to think bigger. We really want to enable this 1 million people to vote and to reach a consensus, and that's where we need a new mechanism. And what Justin Drake proposed in the DevCon is try to use a ZK to aggregate signatures, and we all know that ZK is very good at aggregating things. We've seen great results from all these ZK raw projects. So you will be able to aggregate a lot of signatures into a very short and succinct proof, and then propagating this proof about 1 million validators would be much easier than propagating all the transactions. So that's a general idea there.
Great. And I think you kind of talked about this a little bit earlier, but I guess if we wanted to move faster, or if there was a desire from the Ethereum Foundation to roll this out more quickly, what do you think? How would you suggest we accelerate the timeline?
So I guess this would be the place where you hint about the bootcamp, or should I talk about it?
No, yeah, absolutely. So I think, something that we've talked about internally is like you said, we need people working on these problems. We need more developers putting time and effort into trying to solve these this larger problem, which can be done by breaking it into small, separate modules. And yeah, so I think now is as good a time as ever to formally announce the Explore Expander Bootcamp, which will be launching in January. It will be a bootcamp along with a hackathon. And the focus of the bootcamp will be how to utilize Expander, the benefits of Expander and the GKR protocol, and how to apply these technologies in the context of the Ethereum roadmap and the Beam chain. It's going to be a 6-week program with the first half devoted to education with guest lecturers that we've already lined up from teams like the Ethereum Foundation, Nexus, Stanford, Google, Nebra, Microsoft, Aptos, WorldCoin, and 1KX, with definitely more guests to be announced over the next few weeks. The second half of the program is going to be a very standard hackathon style program where we take the learnings from the first half, from the boot camp, and we apply those to 5 tracks that we have identified. And those 5 tracks will each have a 50,000 grant reward to the top project that comes out of each track. And I think to explain the tracks, Genfei, why don't you tell us a little bit more about the tracks, and maybe we can get into, why we picked the tracks that we did.
Yeah, sounds good. Sounds good. So I do want to mention that we will not be the judge for the tracks. We will have external collaborators from we want to be credit neutral. We don't want to pick winners, and we will let we have invited a few very well-known people in this community to moderate the tracks, and they will help to architect it, try to guide the developers through the design, and then they will help us to pick the best solutions. And us as Polyhedra, our role will be the tech support, help you to figure out ways to use Expander and then to build the solutions. With that being said, so we have five tracks, and those 5 tracks are all building blocks for the Beam chain. From our point of view, we really want to get this, and we think that those are relatively low-hanging fruit that we can build right now. And once they are there, we should be able to accelerate the Ethereum's roadmap significantly. So our first one would be something that we just mentioned a little bit earlier. So this single slot finality, we want to do we have some. Taking one step back. So with single slot finality, what you want to do is to use a ZK to prove that a million people has voted on something, and we really want to just build it and try to see that if this kind of solution is practical already or not. So if it's practical already, then that means we can already try to experiment it and in real world, and then this should help us to improve the overall roadmap. Then I guess should I dive in more?
Well, let me ask you a follow-up. Let me ask you a follow-up question on single slot finality.
Yeah.
When you say practical, do you mean that the performance is fast enough that this could actually this doesn't impact? Because I know one of the things that people talk about a lot is speed and throughput. Are we saying that we can improve the consensus and add to the decentralization by taking into account the votes of 1 million validators without slowing down the block speed and the time to confirmation?
Yeah, I think that's a goal. It would be lovely to have that. But I think the first principle would be try to get 1 million voters consensus first, and then we would. It's likely to with the existing technologies. It's not very clear that it will not slow down the Ethereum. So we will need to make a trade-off there between how many validators and what's the block time, etc. Yeah.
Got it.
But this is something that we really want to explore through this bootcamp.
Got it. And I know the next track in our bootcamp is account abstraction, which I know most people here are probably familiar with account abstraction. But maybe you can tell us a little bit more how zero knowledge proofs can improve the account abstraction experience.
Yeah, sure. So just a little bit background, I guess. So there, with the goal of this, the goal of account abstraction is one of the goals is try to get people get Web2 people, right? We want people to be able to reuse their Google account, reuse their Facebook account, and just use them to authenticate your Ethereum transactions, or whichever chain, like be it Aptos, Sui, Ethereum, or Solana, whichever. But we want to be able to seamlessly integrate or migrate all those Web2 users, and I think that will create a bigger pie for us, and that is more important than picking which chain is better. etc. We want to avoid that, but we really want to make the pie bigger. The way that this zk logins or keyless, the way that you achieve that is through zk logins or keyless logins. That is to say that when Google authenticates you, you generate a zk proof showing that okay, you've been authenticated by Google, and this authenticity or this proof of authenticity will be linked to your Ethereum account, and then then you will be able to use that to authenticate your transaction. So it's a trust chain. If you are from Web2 people, you probably can relate this to a certificate chain or something like that. I guess the tech challenge here is, let's say, to be able to zk proving this authenticity takes time. So there was a really great talk from Aling from the Aptos. He mentioned that in their design they were using Groth16 to prove the zk logins, or they called keyless logins. It took them 13 seconds to generate proof. Imagine that if you want to imagine that you are working with your browser and you want to initiate a transaction, and the browser takes 30 seconds to work on it. And worse even, it will froze on you and telling you that okay, some of the execution takes too much time. So it's a really bad developer experience, and we want to overcome that. What we have is we want to build on top of the Expander, and as I mentioned earlier, Expander is a next generation prover. It enjoys like a asymptotic performance advantage over the Groth16. So our internal benchmark shows that we should be able to reduce this 30 seconds into 1 second. And we are hoping that we actually make this into a product, and hopefully with even further improvements.
Amazing.
Through this bootcamp. Yeah.
And when you were speaking a little bit earlier about the moving to 1 million validators, you were talking about batching signatures together or votes together. Is that why when we put out benchmarks for proof systems like Expander that we focus so much on Kekek hashes or Poseidon hashes? Is that because that performance is something that can be translated to how it may perform on these other tasks?
Yes, precisely. So the major complexity of zk circuits actually come from the all the hash functions. Like 90% of the total computation actually derived from these hash functions, and we really want to accelerate that. Yeah.
Got it. Great. Well, if you haven't already seen the benchmarks on Expander, there we've posted a number of blogs, and I think over the past few months we've 3x'd the performance with regards to the Kekek hash function. We're definitely working on Poseidon hash function, so a lot of progress is being made, and Zhenfei is leading the research on that, increasing and improving the performance of Expander. So by the time this boot camp starts, Zhenfei, I want another 2x on the performance of Expander. Do you think that's possible?
I think we can be more like optimistic on that. We actually see really great numbers once we plug in the GPUs. Yeah.
Amazing. So I know a lot of the work is being spent right now on improving performance through GPUs. Let's get back to the tracks. The next one I want to talk about is post-quantum private transactions, which is another track that we're focused on. I think people are familiar with private transactions, but I did want to use this opportunity to dive into this post-quantum term because it's used to describe single slot finality, where post-quantum signatures are important. It's used in this context for post-quantum private transactions. Can you talk about the importance of post-quantum, which you have a little bit earlier, and specifically how does zero knowledge and how does Expander help us future-proof ourselves for a world where quantum computers exist?
Right. So quantum computers are really powerful. Like they can break RSAs and they can break ECCs. Those are the two like dominant algorithms in cryptography that being deployed. But it's not all powerful. There are some cryptographic systems that quantum computers cannot break. And it's so lucky that Expander or the GKR proof system is one of those. And by building on top of the Expander proving system, you naturally get a quantum resistant. Like I guess the quantum threat, they're like say people say there are. I mean, take one step back. Sorry. People there exist private transactions on Ethereum already, right? So you have Tornado Cash, and if you want to do a different chain, you can use Zcash, and there are Monero, etc. There are so many different flavors out there, but they will, as far as I know, they were all vulnerable to quantum computers. If there is a quantum computer existing today, they may not be able to you may not lose your anonymity, because that's quantum computer can only break the future, not the past. So your anonymity happens in the past. So it may not be able to break anonymity, but once it exists, from that point of view, from that point on, your transactions may not be confidential anymore. And I guess our goal or our proposal would be try to deploy post-quantum transactions as soon as possible. Sorry, post-quantum transaction as soon as possible, so that you don't need to worry about when it happens, and you don't need to worry about some secret state may have a secret quantum computer that's harvesting everybody's information. So that's a goal there. And basically, we put a few buzzwords there, but basically what we're trying to convince people is say, let's build a private transaction using Expander, and you get both speed and a peace of mind about quantum threat.
Hopefully, you get the end game solution, right? Because we're building something that will not break when quantum computing becomes a reality or becomes common. And so if we're working on this problem now, and we have the tools to build something that's post-quantum secure, we might as well do it.
Yes.
All right. And that's going to be used, I think, the importance of that in both single slot finality and private transactions, which are two of the other tracks. So now we have our last track, which is ZKML.
Mm-hmm.
If you are following Polyhedra on Twitter, you're in the Polyhedra community and you keep up with our announcements, you've seen we've been doing a lot of work in the AI and ZKML space. So I'm particularly excited about this track. Can you share some more information on our recent breakthroughs that we've achieved over the past year, and how that's going to translate for the participants, both in the bootcamp and the hackathon?
Right. So before answering that question, I want to just rewind a little bit, like 5 years ago. I mentioned that I read about Tiancheng and Jiahan and our co-founders' paper, right? So, and actually the first paper that I read about them was about this so-called ZK-CNN paper, that is to use ZK to prove the convolutional neural network. So that's actually the breakthrough, that the eye-opening, the first paper on the ZKML subject. The reason that I was working on I noticed that is that I was also working on a similar idea, which is called Zen, but our performance was not as good as the ZK-CNN because we use a different prover, and that's where I get into learn more about GKR prover. I think it's a better prover than the prover that I used in my paper in 2020. So by then, I think the market was not ready, and the OpenAI was not thing yet, and people don't worry about AI safety. But I think a lot of the landscape has changed really a lot. Like nowadays, AI safety is not a sci-fi fiction notion. People really care about verifiability of your AI, right? And this is also something we are aligns with our goal. Like we want to future-proof. We don't want to leave the leave a mess for our springs, right? So and we have the technology to save it right now. So let's build it. Concretely, so what we have seen so far, and this is after I joined the Polyhedra, what I learned is that with the new expander prover, we are able to further accelerate the performance compared with the previous one. So compared with the papers that TC and the guys did and what I did 4 years ago. So at the moment we can even prove a llama model with 8 billion parameters within reasonable time. So previously, I think the world record or the best known record was from Modulus Labs, and they did a 1.5 billion parameters model within like 95 hours. Yeah, 95 hours. And with us, we were able to do a 8 billion parameters within 150 seconds. So that's, I think, like 3 or 4 orders magnitude improvement. And I think this is the final time that we are seeing this ZKML gets into the practical domain. Like you don't. I mean, let's put it like 150 seconds is not like a blink, but it's not so. It's not like you need to wait for 3-4 days to get a result. And we are committed to. So that's our tech. And what we want to build with this tech is try to actually deploy it on chain and try to get some applications out of it. So, so one thing that we have brainstorming about is, like, say, we can do a VGG model or a smaller model where you can really get a proof with your snap. And those models are useful. Let's say you may notice that there was like WorldCoin, they had these iris scans, and they used to you use ZK models to make sure these iris scans are authenticated or legitimate. And we want to do similar things. We want to say, okay, we have some images and we pass it through some small models, and we put the result of model on chain. That's kind of a part of the authentication of your IDs or this kind of thing. I mean, we can be very innovative about the actual applications. So this track is actually very open to different applications. So if you are AI developer or if you are ZK developer who wants to get into AI, come and you try to use our tools. We name our tool chain ZK PyTorch. So what it means is that you can just write PyTorch and pass it through our compiler. It will generate the expanded proof for you. Very easy. You don't need to learn anything else. Just streamline PyTorch, and you get a proof on chain. So yeah, so that's that's our last track. Come and build with us.
Yeah. So I guess one more question or one more observation. You kind of mentioned, zero knowledge proofs have been around for a while in academia, and it wasn't until a few years ago that the performance got to a point where it would work for something like interoperability or ZK rollups. Mm-hmm. Based on what you're saying around ZKML, it seems like we may be entering a similar time period with AI, where a lot of research has been done in academia around verifiable AI, ZKML, and it's not until right now, and potentially due to some of these next gen proof systems like Expander, that performance has gotten to a point where we're moving from theoretical into practical and reality. Would you say that that's a reasonable thing to say?
Yeah, precisely. I would say, like, I would just give you an example. Like, I would use a hash function again as an example. So the 4 years ago, that's around the time where the Plonkish based solution came up, and they with say the Halo 2, which is one of the dominant Plonk proof system, it takes like 1 second to prove 2 keychaps. 4 years later, now today, we are able to prove like 10,000 keychaps per second. That's 4 orders of magnitude improvement. And I would not be very surprised if we see again 4 orders of magnitude improvement for the ZK ML in the next 4 years. And I think it will be good if you get into this space right now. It's like you invest in ZK 4 years ago.
There we go. Well, that is a really strong endorsement for this. I will just go through the tracks one more time for everyone on here. So the 5 tracks are going to be stateless clients, account abstraction, single slot finality with post-quantum signatures, post-quantum private transactions, and ZKML, which sounds like, it's pretty much going to be a blank canvas with ZKML. There's so many opportunities to utilize ZK PyTorch to turn AI into verifiable AI. With that, I'll just say if you're interested in participating in the hackathon, we will be opening up registration in the next couple of weeks. If you are interested in participating and you just want to make sure that you're informed, feel free to DM me, DM Zhenfei, DM the Polyhedra account. We watch all of them. We will get back to you. We are really excited to teach everyone about Expander, continue this kind of march towards the Beam chain, the acceleration of the Ethereum roadmap, and we're excited to work with developers that are excited about the next gen of zero knowledge proof technology, but also that are aligned with our goals of building towards the future of the Ethereum and the Beam chain. So with that, I think I'll bring our lovely host Tony back in. Tony, you want to hop back in? I know we've got a few minutes for some questions for the audience.
Yeah, absolutely. Thank you, Eric. And can you guys hear me okay?
You're great.
Awesome. Just had a few little issues there. Thank you guys, both of you guys, for sharing a little bit of your origin stories. I know that I appreciate hearing that. I've heard it before, but I always appreciate it. And I know that we're getting a lot of love from the community as well to hear that from you guys. Obviously, Expander it's a foundational leap forward. I think from the community, I'm seeing that it's still a little bit of confusion there with just what that means. So I'll jump right into it. So from Kentai, how accessible is Expander for developers new to ZK technology? Are there any tools, documentation, or support systems in place to lower the barrier to entry?
I would love to take this one. Please come to the camp. We'll have all the education. We'll have all the education materials, and you won't be disappointed with all our great, really world-leading lectures that we have gathered. But if you are already in this ZK space and you've learned a little bit about ZK, then you probably have heard of GNOC or GNOC, which is a ZK tool that developed by the Consensus team. Our front end is fully compatible with GNOC, so if you have a GNOC ZK, you can just plug in our toolchain and it will generate Expander proof for you.
Great.
Awesome. I might shoot another one straight back at you to follow on. So what impact do you believe Expander's advancements in proof generation speed will have on the overall adoption of ZK technology across decentralized systems? I think this is a great question for both of you guys.
Right. When you look at the Beam chain's roadmap, I don't think it can be done without ZK. So ZK will be essential. So that's my, general answer. So how impactful it will be.
I think the fact that, Zhenfei and I, work at Polyhedra, we're a little bit biased, but I think we think that there are so many opportunities for zero knowledge technology, not only in the context of blockchain, but also in the context of AI and ZKML and identity and there's so many applications where the properties of data privacy, scalability are going to be useful, and we are just starting to scratch the surface of what's possible with zero knowledge. And like Zhenfei said, we're still in the first inning. It's not too late to jump in. I think that there is going to be huge advancements in the performance over the next few years, and huge advancements in terms of practical applications and the way developers are utilizing these tools to solve really difficult problems.
Awesome. I personally loved hearing about, post-quantum. That's super exciting, and I didn't realize that beforehand, that it's like pre-quantum and post-quantum are actually two different worlds. And it's like kind of, if you get your foot in the door beforehand, which was really, really insightful. So thanks so much. I've had a few comments on speaking to the same. But getting back to more like what's happening right now. So outside of non-financial applications asked by Ethan, such as supply chain management or healthcare, can Expander be applied to these?
I would say that the Web2 is like a blue sea that we really need to explore further. I don't have any intuition here. Like Expander will act as like any other leaky-proof systems. Like there isn't any new features that we can provide for, say, supply chain management, etc. I mean, that's for my personal view, but
yeah, I will say this. I mean, Expander is, a very low-level foundational piece of a zero-knowledge proof system. And then there are these tools that we're building on top of them. And one of them that we were just referring to is ZKML. And Zhenfei mentioned, this is a very open track because there's so many different areas that you could apply this to. In finance, verifiable AI is important. In healthcare, in marketplaces, specifically data and compute marketplaces, supply chain, entertainment and IP, privacy preserving. We've spoken to that, and AI agents. When you start to get into a world where AI agents are given some autonomy to go and act on their, the behalf of someone else, there needs to be verifiability, there needs to be accountability, and those are the types of things that ZKML unlocks. And we are just at the very beginning stages of what we're going to see. So I think that, if you have questions about a particular focus area, if you work in a particular industry and you're trying to brainstorm and come up with ideas on how you can apply Expander to your particular vertical, I would encourage you to come and show up to the boot camp or office hours. We'd be happy to talk with you and see if we can find a way to help you leverage the technology that we're building in whatever interest or passion or professional capacity you work in.
Super exciting to see what comes from the bootcamp. I know I'm really, really excited from it. And I know that you touched on that there are the 4 tracks. I do have a few people that are asking again how they can get involved. Eric, I know you just touched on it, but maybe we can just elaborate on that again just for the new participants. And they're talking about just the 4 tracks. We did cover that, and what rewards. I know you said that there are certain rewards, incentivizations for the people who are leading those tracks. Can you just touch on that again briefly?
Yeah, absolutely. So the 5 tracks are, let me just pull them up. Single slot finality, stateless client, account abstraction with ZK login, private transactions, and ZKML. And as we mentioned earlier, there will be grants given out to the top projects in each track. We will not be the judges for that. We will have credibly neutral, independent moderators who will help us select those. But and as good as the opportunity to get a grant is, I think that probably something more valuable that Zhenfei alluded to earlier is really learning how to utilize this incredibly powerful technology that is just getting started. Not only are there applications that are going to be able to help push Ethereum development forward and the Beam chain forward, but everything that you learn on this is going to be applicable to so many different areas, from Web3 to, other industries as well. And then if you want to get involved, I would say follow the Polyhedra account on Twitter. You can feel free to DM me, Genfei, or the Polyhedra account right now. We are currently working on the website for the bootcamp and hackathon, which will have a registration process. But if you DM us, we'll make sure to share that with you as soon as it's available. We will also put out a handful of announcements between now and the start date. So if you follow the Polyhedra account, you won't miss it. I guarantee it.
Awesome. Thank you so much for elaborating on that again, Eric. I know that we're a little bit short for time, guys. I know you have a super busy day ahead, but I would love to ask you guys, what are you most excited about for 2025? I know the bootcamp is probably top of that list, and that's the first thing off the block. But I'm sure that there's other things that you're super excited about. You're both obviously thought leaders in this space, and you know what's going on. So we've got a lot of people who are asking the same question. What's on the vision board for you guys for 2025?
Go ahead, Genfei.
All right. So I was going to take one more minute to think about it, but okay, that's fine. I'm really excited about massive adoption of the GKR Pro systems. We've already seen this trend in 2024, and we want this to go through till the next year. And we really hope that this technology can be utilized by a broader community and can benefit the broader community.
Yeah, I will echo Genfei's answer in that, just over the past 2 or 3 months, once we started to put out the benchmarks, once we started to put out the toolkits to make development easier, we have already started to see a significant increase in the interest and demand from teams that want to build with Expander and the GKR protocol. So I'm excited to see that continue to increase and hopefully grow exponentially, although I know that Genfei likes linear.
Linear is even better.
But I think beyond that is also obviously EXP chain. And if you guys, I think it's pretty obvious, but the reason it's called EXP chain is because it's based on Expander. A lot of the functionality that we're trying to develop, in this bootcamp are questions and areas that we're thinking about for EXP chain. We want it to be the everything chain for AI. We want it to be the place where if you're building an AI application, it has everything that you need on one chain. And so I'm excited to continue to grow EXP chain, to see the progress that we make with ZKML, to see and verifiable AI, and as Genfei mentioned, to see the progress that we make with Expander, because although we've seen tremendous growth over the past few months, I think we're going to see even more next year.
Awesome. Thanks so much for the insights, guys. I wish you guys, I know that it's a broadcast, so you can't see all of the comments live, but a lot of people loving this live stream and really appreciating the knowledge and depth of knowledge that you guys have brought, and myself included, actually. So I always appreciate listening to you guys. So thank you so much for answering all the questions. Great fireside. Just for the community, again, sorry, I can never get to all the questions. There's always just way too many, but I try and pick the most the best ones that I can, but it's a lot to go through, guys. And again, we're going to do this a few times a week, so I'll absolutely try and get to all of these as we roll out. Again, keep it coming, you guys. We love the engagement and love how much you guys bring to the table here. If you want to connect, again, any one of our streams, these guys are giving you a whole lot of information about the boot camp. It's going to be really, really exciting. If you want to get involved, I did see a few of you asking how you could get involved. I think Eric summed that up for you guys. So it's going to be a really, really exciting 2025. just hearing your guys' perspectives and your vision board for 2025 is definitely going to be a pin up on mine. So yeah, really, really happy to wrap this up, guys. And thank you so much for your time again. And we'll see you all next time.
Thank you, Tony. Thanks to the community. We will be back. And thanks for all the great questions. Really appreciate your time.
Thanks, guys.
All right.
See you next time.
Bye.
Bye.